Thank you for visiting our Operational Intelligence Marketplace. Today we have a team from MapR to talk about their technology. Jack Norris, the VP of Marketing, John Benninghoff, the Solutions Manager, and Nitan Van de Gula, the Product Marketing Manager. So I'm going to turn it over to you, gentlemen, and take it away.
Okay, this is John Benninghoff. So up on the screen is a screenshot of a MapR cluster management console. And this is hosting, as you can see, a very large cluster. There's a heat map on the left represented by the green and red and orange boxes. And it's organized into racks. So this is our dashboard. When you first encounter the MapR control system, this is the page that you see. You get a dashboard to get a high-level overview of the entire state of the cluster. And this one is showing, the size of this one is multiple racks, many servers per rack. And you can see that one rack in this case is down probably for maintenance and showing the capabilities here. On the right, there's cluster utilization at the top, kind of giving you a high-level CPU utilization, where CPUs, memory, and disk are at, how our services are running, where they're spread out. And I'll go into a live interface as well. This is just a static view to show the size. And then volumes and showing our volume capability, and then the MapReduce jobs that are actually being executed at this time. Okay. So let me switch now to an actual running cluster.
And that interface expands. So when we have, clusters like 1,000 nodes, you'll see those, small little boxes and be able to view across multiple dimensions, and whether it's CPU load or health or what have you.
Right. So now here's an actual smaller cluster, but actually a live interface to it. And on the left here, you can see the control. The tree that provides the overall control. This is always visible, so you always know where you're at. You have context, always have context. As you access items on the tree, they show up on the right here. So we have the dashboard on the left, as we did before with these frames showing the various state of components of the cluster. Then one of the more compelling features of our version 2.0 or 2.1 that's shipping now is the jobs metrics. So this is unique to MapR. So the way that the job metrics are currently handled in traditional Hadoop is that the log files are just spread out amongst all the nodes. So you can imagine if you have hundreds of nodes, if you got to go look at hundreds of nodes to look at log files, it's an extremely tedious and error-prone task. We consolidate that all into this view. And so you can see on the bottom we have a table that shows the jobs that have been run. And these are various. I've been doing a lot of testing, so there's these jobs that I've been running. And then what we get on above that is a nice chart that shows you job count by duration. So on the x-axis is the duration of the jobs, and on the y-axis is the count. So you see most of these were trivial little small jobs. Some of them were larger jobs. In this case, this is a small cluster just for testing purposes. But you can have other views as well. So that's the job duration view. But you may want to see other things like how many map tasks were done per job. And so you can take a look here and see that on the x-axis is the map task count, and the count is on the y-axis, and the quantity of jobs that had 14 tasks, for example, or 10 tasks are shown on the y-axis. Any questions about this? Does this make sense, the interface?
Yep.
So as you can see on the left, you can go in and you can examine more aspects of the cluster. You can look at our volumes and take a look and see the size, the utilization.
What's important about volumes is it gives you a logical way to slice up a cluster, so you don't have to do policies at an individual file level or have separate clusters because of disparate workloads. You can have volumes to set up different data protection policies, access, group access, member access, etc. And then we have nodes, being able to focus in on the nodes, find out the state of those nodes, get a high-level view of performance on those nodes. For somebody who's administering the cluster, this is a useful view. We have NFS setup. We can, for our NFS interface, we can show the snapshot screen, how you set up snapshots. No records. okay.
So we have, this would be the screen where we can set up snapshots. In this case, I haven't done any snapshot work yet on this one. And then we have the ability to handle alarms. So if you noticed in the dashboard, there was an alarms frame here. In this case, it's just a notice that the license is expiring. But here's where you would get things like disk failures, nodes that are down, and you can see the alarms. You can configure the alarms through this interface. And then there are additional system settings that you can go in and address here. And so this is the high-level view of what the management console provides. Are there any kind of questions on this? Does it make sense?
Yep.
Okay, so let me move on to the next demo. So the next demo is the M7 HBase demo. It's a video, and I'll just explain what is going on here. So this is another clusters management console interface. This is version 3.0. You can see there are no region servers in the services pane here, where normally you would see those with traditional HBase. And then if you go to the Finder or the File Explorer, we can actually see the file system and explore it, and we can go in and we can actually see a table, and we're going to rename it here. So a table is just an object in the file system, just like a file or a directory. So we've renamed it to users. And now we go into a shell and then open up the HBase shell, which is a traditional interface for managing HBase. We'll take a look at that table that we renamed, dump it. You can see it's a small, simple table with this data in it.
Right.
And then we go and look at the volume that contains that table. And we'll go and make a snapshot of that volume. We're talking about the ability to create snapshots. So here we're creating a snapshot specifically for that volume that contained that table. And then we go back to the tables and look at them through the management interface, and we see the table there. And so we're going to deliberately delete it, as a user might do accidentally. Delete that table, and now in a normal file system that would be gone forever, and there's no turning back. But in our case, we can go take a look at that snapshot that we took.
And that's a unified snapshot, so we're snapshotting both files and tables in that directory.
Oh, wow.
Keep separate.
And we dump the table, so we see it's there. So we'll create a new table, call it profile. And then we'll use a standard copy table capability that HBase provides, and we'll copy the snapshot data into this new table and get it back in so that it's preserved exactly as it was.
So basically that's reading directly from the snapshot. There's no region server. There's no kind of reconfiguration time.
You didn't have to bring down the HBase system. And there's a lot of work that had to be done.
No, I mean, this is going to make HBase users, I mean, people who are using it in anger anyway, this is going to make them, I would have thought, reasonably enthusiastic.
Yeah, there's a lot of, I mean, that was just a brief, taste of M7, but, you look at the simplified environment, the ability to have consistent low latency that's not impacted with Java garbage collection or not impacted with actions, and you've got, basically optimized both read and write amplification. It's basically a game changer for HBase.
Yeah, simplification just buys you a lot of reliability in. So the final demo here is back to the streaming rights. So this is integrating Hadoop with Storm, and this is actually a live. You can go to realtime.mapr.com yourself with your browser and see firsthand. This is live Twitter information as it's feeding in, and we're feeding this into our simple. It's a relatively small cluster doing this, all this work, because of the capability. We could compact it into a small, simple cluster and still service a reasonable Twitter feed.
Right.
So the advantage here is that because MapR uniquely supports streaming rights, there's no separate collection cluster that's taking this data And our ability to integrate with Storm is direct. We have a spout in MapR that services Storm. So the data is collected through MapR, serving this Storm application directly. And that means that same cluster that's serving this real-time capability can also be used for predictive and batch analytics. So, you know, Robin, I think this is another area where people are more than a little bit enthusiastic.
Well, yeah, I can imagine. I mean, I think it's like what I said before. It's like, you know, streams is a fine thing, but not everybody actually has any need to. Well, they probably want to catch streams properly in Hadoop if they're doing it, but mostly if they're really interested in a stream, they're probably processing it before it hits any storage point. However, just the ability, like I said, not to have to do batch writes. I mean, I can just think of lots of different situations where actually that really is going to pay. And I think that's the big deal here. And as long as people understand that you know, that's one of the advantages here, then I think they'll appreciate what you've done.
Yeah, because any analytic, any operation that's, you know, real time or near real time, the ability to have that be performed on data that is recent is real important. So the fact that the underlying platform is not going through some, you know, long frequency batch update is a major advantage. So,
yeah, I mean, even in analytics, you know, in analytics, there's lots of intermediate sets that people, you know, that the data analysts might create, and either that sits in memory or you commit it away somewhere. But if you commit it away and it has to wait a long time before it's committed away, it's just a delay you don't want. So this, you know, this too, you know, in that situation, which is really a kind of batch processing situation rather than streaming or even anything that's like transaction processing. But even in that situation, you care about the rights. I mean, there's no question you care about them.
Well, and one of the things we're seeing that's in stark contrast with kind of traditional data warehouse or analytics that's kind of batch-based and based on kind of historical views, is we're seeing operational intelligence being done as data arrives and to do things that impact the business directly, whether it's digital media where it's doing, you know, ad serving, or you're doing kind of predictive failure analysis, or you're doing couponing, or you're doing fraud detection. All of that being done in Hadoop and doing it, you know, as the data is being conducted or as the business is being conducted is what's really moving the needle for organizations. And yes, it's being used, you know, later to do, you know, historical analysis and deeper analytics, but it's those automated applications that are being done that impact the business that are really returning these significant insights and significant business returns.
And without having to copy the data, right? You've got a single copy of the data, you know where it's at, the same data, not creating copies of data is huge operationally.
Yeah, well, guys, this is neat.
Thank you very much. We appreciate this. This is excellent.
Yeah, this is, appreciate your time. Yeah.